Hi, mathletes. Today we're going to find the least common denominator, also known as the LCD. So in this video, we're going to explore how to find the least common denominator using a visual strategy called the big one, and then we'll use this method to help us understand why we need a common denominator to add or subtract fractions. We're going to use the big one to find a shared denominator and the matching numerator for each fraction. And we're going to rewrite fractions as equivalent forms with the least common denominator. So let's see how the big one helps us both in finding the denominator and the new numerator, so our fractions are ready to work together. So first we're going to find the least common denominator, and we have the fraction of 3/8 and 5/12. So you'll notice that they have different denominators, so we need to find a common denominator for the 8 and the 12. We can do this by making a factor tree. Now, if you don't know how to make a factor tree, I have a video on it, so you can just use the QR code and watch that video and then come back to this for finding the least common denominator. I am going to use a factor tree in this video, but I'm going to go rather quickly. So again, you might want to watch the other video. So again, we're going to find now the least common multiple. So the least common denominator and the least common multiple actually mean the same thing. It's just now we're looking at the denominators, the 8 and the 12. So we'll make a factor tree with 8 and 12. And for 8, I can say 2 multiplied by 4. 2 is prime, so I circle it. And 4 is 2 multiplied by 2. So I circle that. So those are my primes, 2 multiplied by 2 multiplied by 2. For 12, I'm going to say 6 multiplied by 2. 6 is composite, so do not circle it, but 2 is prime, so circle the prime. And for 6, I can say that it's 2 multiplied by 3, and they're both prime, so circle it. Okay, now I'm going to list out my prime factorization for 8 and for 12. So for 8, it was 2 multiplied by 2 multiplied by 2. For 12, it was 2 multiplied by 2 multiplied by 3. Now notice that I moved the 3 over here. I didn't put it under the 2. I only line them up if the number is the same. And since I only had 2 2's, I need to leave a space here and then put my 3. Now I'm going to make these into columns. And I'm going to bring down each number in the column. So I brought down a 2, the 2, the 2, and the 3. And then I multiply the numbers. So the product of 2 and 2 and 2 and 3 is 24. So the LCM is 24, which also means that the lowest common denominator for 8 and 12 is 24. So now we're going to use the big one to write in equivalent fractions. So we had our 3/8 and our 5/12. I'm going to multiply this by something called the big one. And I know that my common denominator is 24 for both 3/8 and 5/12. So I need to think, what can I multiply 8 by to get 24? And I know that it's 3. So I multiply 3 over 3. So 3 divided by 3 is 1. Remember, I'm not changing the value of 3/8. It's going to be the same because I'm multiplying it by 1. And anything multiplied by 1 is itself. So 3 multiplied by 3 is 9. So 3/8 is equivalent to 9 24ths. But now they have the denominator of 24. We'll do the same thing with 5/12. What can I multiply 12 by to get 24? And it's 2. Again, 2 divided by 2 is 1. I'm not changing the value of 5/12. It's going to be equivalent. So 5 multiplied by 2 is 10. So 10 24ths. Notice now that they have the common denominator. So now if I need to add or subtract, I can because they have common denominators. So the least common denominator, or LCD, helps us turn unlike fractions into compatible parts for adding and subtracting. Using the big one, we were able to find a shared denominator that both fractions can fit into, and we used the model to find a new numerator for each equivalent fraction. We turned unlike fractions into like ones, ready to combine. And we made fraction operations clearer and more visual. So math isn't just solving, it's understanding how and why things fit together. Thank you so much for watching. And if you liked the video, click a like, leave a comment, or better yet, subscribe. I would love that. Again, thank you for watching.